Good afternoon, everyone. My name is Ko Jiang Huan. My presentation focuses on the role of engineers in shaping sustainable and ethical technological future, specifically looking at the Malaysia Smart City Initiative. In these discussions, we will explore how engineers are transforming cities through smart technologies, how this innovation brings economic, social, and environmental benefits, and the ethical responsibility that come with this progress. Ultimately, the goal is to understand how technology can serve people, not the other way around. Here what I will be covering today. We begin with the overview of the smart city concept and Malaysia's direction in implementing it. Then we will analyze both positive and negative impact across for four areas: society, economy, environmental, and governance. Then next, we will discuss how sustainability principles are integrated into smart city design. Finally, we will examine ethical and legal issues and how engineers can resolve this challenge to ensure that technology remains responsibility and inclusive. So first, we are talking about positive impact in society. Let's begin with this social impact. Malaysia's smart city initiatives such as the AI photovoltaic vision in Putrajaya (AICT) provide clear example of how engineering and artificial intelligence can improve daily life. For instance, AI-enabled traffic management systems have reduced congestions by nearly 80%, meaning less time wasted, less stress, and lower fuel consumptions. At the same time, smart video analytics (CCTV) have improved public safety by allowing faster emergency response and proactive crime detections. Millions of data points collected by urban observatories help authorities respond faster to accidents, floods, or disasters. In short, smart engineering solutions are directly enhance community well-being and building safer, more efficient cities for everyone. And next is a positive impact in economy. Economically, smart city technologies are driving growth and investment. Malaysia's smart city framework attracts international collaborations and stimulates local industry in AI engineering, data analytics, renewable energy, and cybersecurity. The public-private partnership contracts, or PPPC, showcased at the Smart City Expo Kuala Lumpur 2025, highlights how government and private sectors can co-develop high-tech infrastructure. This partnership model strengthens the economy by creating high-skilled jobs, supporting local startups, and positioning Malaysia as a regional technology hub in Southeast Asia. In short, engineers are not only solving urban challenges but also building a robust, innovation-driven economy. And next is we move for the environment impact. Malaysia aims to reach 31% renewable energy generation by 2025, and engineers play a critical role in achieving that goal. Through AI monitor solar and wind systems, smart city optimize energy distribution, reduce carbon emission, and ensure energy efficiency. Smart air quality and flood sensors collect real-time data that allow authorities to act before problems escalate. For example, by predicting floods or pollution spikes. This integration of environmental data and engineering intelligence leads to more sustainable city planning and stronger climate resilience. In essence, smart technologies are not just making cities smarter, they are making them greener. Right? Slide 6. Negative impact, social and economy. However, as engineers, we must also recognize the risks and ethical concerns behind these technologies. First, AI surveillance can collect vast amounts of data about individuals, creating serious privacy issues. It can lead to profiling, discrimination, or misuse of personal data. This raises ethical questions about who owns the data and how it's used. Second, not all citizens benefit equally from smart cities. There is a risk of growing digital divide, where wealthy urban communities gain access to smart technology, while rural or low-income groups are left behind. Economically, the heavy reliance on automation could also lead to job displacement, especially for low-skilled workers in administrative and maintenance roles. Finally, building and maintaining smart infrastructure is expensive, and this cost often fall on taxpayer or smart business. Without careful planning, it can increase financial equality rather than reduce it. So next, talking about the negative impact for environmental and governance. There are also environmental and governance related drawbacks. While smart technologies save energy in some areas, data centers, which power AI and cloud computing, consume massive amount of electricity. So ironically, they can increase country carbon footprints. Additionally, old or damaged internet or things devices contribute to e-waste, creating new sustainability challenges. In means of governance, smart cities depends on interlinked systems, water, energy, transportation, and data networks. A single system failure can trigger cascading effects across the city, disrupting essential service. Centralizing too much data also increases the risk of overreach or misuse by authorities or corporations. This issue highlights the need for strong governance, cybersecurity, and transparency in smart city management. So for to mitigate these challenges, engineers are integrating sustainability principles into every stage of smart city development. For example, smart energy control system automatically adjust building lighting and climate setting based on occupancy, reducing unnecessary energy use by over 30%. Renewable energy microgrids ensure a more resilient and decentralized power supplies. Engineers are also improving resources efficiency, using IoT leak detections to reduce water wastage by up to 40% and optimizing waste collection routes through AI-enabled smart binds. Moreover, applying circular economic frameworks encourage the use of recyclable and repairable materials, extending the life of devices and infrastructure. This engineering approach ensures that technology support long-term environmental and social sustainability. Okay, now let's focus on the ethical and legal dimensions, perhaps the most crucial parts of this discussion. First, data privacy. For Malaysia Personal Data Protection Act (PDPA), updated in 2025, now mandates data protection officers are breach notification. However, enforcement remains limited. Engineers must adopt the principle of data minimization, collecting only the data necessary and ensuring it's encrypted and anonymized by design. Second, cybersecurity. With interconnected systems, the threat of cyber attacks increasing dramatically. A single vulnerability is a smart grid or transport network can affect millions. To prevent this, engineers should design zero trust architectures, use mandatory IoT encryption, and conduct regular presentation tests. Third, social inequality. To ensure fairness, engineers should design inclusive systems such as a public Wi-Fi for low-income communities, subsidized device, and digital literacy programs. Technology must empower everyone, not just those who can afford it. Fourth, job displacement. Automation must be accompanied by retraining and reskilling initiatives. Engineers can help by developing just transaction programs, funding retraining, creating digital apprenticeship, and design systems that support rather than replace human works. Finally, algorithmic accountability. AI systems must be transparent. Engineers should implement algorithmic impact assessment and regular audit for bias, ensuring that automated decisions can be explained and appealed by the public. Through these frameworks, engineers become not only innovators but ethical guardians of technology. So in conclusion, Malaysia's smart city initiative represent both opportunity and responsibility. It shows how engineering can shape a nation's future, improving society, stimulating the economy, and protecting the environment. But at the same time, it reminds us that technology without ethics can lead inequality, exclusion, and loss of trust. As engineers, we hold the responsibility to ensure that innovation is always guided by integrity, sustainability, and empathy. Our task is not just to build smart system, but to build a better society, one that is inclusive, resilient, and fair. A truly smart city is not defined by its technology, but by its human value. Where engineers combine technical excellence with ethical foresight, they shape not just smart city, but a sustainable and ethical future for generation to come. Thank you.